Today an opponent plays rock, paper, scissors against us. Every line in our input represents one round of rock, paper, scissors. The A, B, and C stand for the opponent's rock, paper, scissors, and the X, Y, Z stands for our own rock, paper, scissors. As usual, it's a good idea to split this one long string into multiple lines. This would be the desired result. If we look at the input, we can see, well, we have our new lines, but again, we have these spaces here because my IDE likes to indent with spaces. And we learned yesterday how to split. That would be string split S by new lines followed by an arbitrary amount of spaces. And then the first test already passes. Now every round is scored depending on the shape that we play, 1, 2, or 3 for rock, paper, scissors, and then more importantly, losing doesn't gain additional points, but drawing gives us 3 additional points, and winning 6. So the worst move is losing with a rock, that would be 1 point, and winning with scissors would be 9 points. Okay, now there's only, well, 3 possible choices for my opponent and 3 possible choices for me, so that would be 9 combinations. Why don't we simply list them all out? So I simply wrote a hash map here. If we look at the hash map quickly, here you can see it. So this would be the 9 possible combinations in our string form mapped to their corresponding values. Here's our best move and here's our worst move. And the order is different than in the source code because hash maps don't have predictable order. Right, so here are the 3 combinations where the opponent plays rock, here where he plays paper, and here where he plays scissors. And within each of these groups, I can, of course, also play rock, paper, or scissors. And then depending on whether I play rock, paper, or scissors, I give myself the rock, paper, scissors bonus. And then, well, we have to think a bit. So rock draws against rock, paper wins against rock, and scissors lose against rock, right? So we have to know the rules to fill out the second bonus here. Okay, and similar for the next 6 cases, of course. Right, so what can we do with this map, apart from just printing it to the terminal? Well, in Java, we would say something like scores1.getAx. That would be Java syntax. And in Clojure, we write the function name first. That's a special function. That's not the method on Java maps. Get scores1 and then AX. And that gives us the exact same result. Okay, and interestingly, we can get rid of the get. We can say scores1AX. That works as well. So we can treat maps as functions that take a key and return a value. That's quite useful. And in mathematics, functions and maps are basically synonyms anyway. Okay, so now for part 1, what do we then have to do? Well, first, let's see. We start with our rounds. And we want to, of course, execute this test. We start with our rounds. We have to split. Let's start with that. So that would be split lines the rounds. Then it looks like this. And then we have to map the rounds according to our scores map. So that would be a simple map function. Map the scores1 map over that. And then we have 8, 1, and 6. And then we want to add them up just like yesterday. A reduction with plus and 0. Right. And also, just as yesterday, this can be optimized. We can say transduce instead of reduce, and then map scores1 is our transducer, and split lines rounds is exactly the same. So this is just an optimization so that the map doesn't have to materialize in memory. Right, and I did something wrong. I think this belongs here. Right. Cool. So maybe immediately copy paste this so we have it for part 2. Now what changes in part 2? The meanings of my characters change. So X, Y, and Z no longer mean shapes, they mean outcomes. So what did I do? I simply copy pasted this entire map where the second character was, had a correspondence with the shape. I simply copy pasted that down here, and then I simply looked at the outcome and inserted the correct character here, right? So draw is Y according to the new spec, win is Z according to the new spec, and lose is X according to the new spec, right? So only the second column character here changed. Everything else is just copy paste. Okay, and then we can use the same code. Of course, we have to use scores 2 instead of scores 1. And we can see if I comment in the tests that now all 3 tests pass. Right, and you may say, using a map as a function is still somewhat weird to me. So let's see the map function. The map function expects another function and not a map, right? So let's look, what does it actually do? So here is the arity that only takes a function, and here is the place where that function is actually applied to an argument. So here is where the string is passed in and where a score is returned. Why does this actually work? So the scores2 is a persistent hash map. And if we right-click on the persistent hash map, then we can see that it implements the ifun interface, basically Clojure's function for, or interface for functions. And if we right-click on that, we can see it's a rather large interface with lots of different overloads for different arities of calling a function, here without an argument, here with 1 argument, 2 arguments, and so on, up to a variable arity. And this is the function that is actually implemented by hash maps, where a key is passed in and a value is returned. And that's why you can pass maps to the map function.